In this video, we'll learn how to multiply all types of polynomials together. We begin by looking at how to multiply two binomials together, and then we'll expand that to other types of polynomials. It helps to visualize what the product of two binomials might look like. And to do that, we'll look at ways of calculating the area of a rectangle. So if we look at the rectangle shown here, we can see that the length could be written as x plus 7, and the width of our rectangle could be written as x plus 3. So to find the area of this rectangle, we would need to multiply x plus 7 with x plus 3. This is our binomial multiplication. Another way of finding the area of this rectangle, however, would be to find the area of each of the small parts of our rectangle. So to do that, we could do four little multiplication problems, four little area problems. X times x is x squared. So the area of my green rectangle is x squared. And I do that three other times. 3 times x would be 3x. 3 times 7 would be 21. And 7 times x would be 7x. So the area of this total rectangle would be all four of these smaller areas added up, which is represented in this example, x squared plus 3x plus 7x plus 21. We could, of course, simplify that and say that the area, if we combined like terms, is x squared plus 10x plus 21. So what does this mean about multiplying two binomials? What process could we follow now that we understand this? Well, we could see that multiplying each term of the first binomial, in this example, each term with by each term of the second binomial is essentially what we've done. X times x, x times 3, 7 times x, and 7 times 3. We're distributing each term of the first with each and multiplying with each term of the second. So this is our rule for multiplying any polynomials. To multiply any two polynomials, you multiply each term of one polynomial by every term of the other polynomial, and then you combine like terms. So I have this example, x plus 5 times x plus 4. It's two binomials together. I could draw a little picture using a rectangle to do this, and then figure out what our four smaller products would be for smaller areas, and then add all four of those up. So that would be x squared plus 4x plus 5x plus 20. And then when I combine my like terms at the end, x squared plus 9x plus 20. That's the product of these two binomials. However, we don't always want to have to draw a rectangle when we multiply polynomials together. So we can again think about this process without drawing the rectangle. So I'm going to multiply each term of my first binomial with each term of my second, and then I'll do the same thing with each term of my second term of my first polynomial. So x times x squared is x to the third, and x times negative 2 is negative 2x. Then I'll do that same distributing with my 6. So 6 times x squared is positive 6x squared, and 6 times negative 2 is negative 12. I then look to combine like terms, and in this case I don't have any, but I would still prefer to write this final answer in descending order. So I'll rearrange the order of my polynomial, of my product, to get this. When multiplying two binomials together, there's actually a little process that you can think about to make sure you don't miss any steps, any multiplications. And it's the acronym FOIL, which stands for you multiply the first together, the outer two terms together, the inner two terms together, and then the last two terms together. So if we use FOIL, and this only applies for multiplying two binomials together, but this helpful acronym can help us. So I multiply my first two terms together, x times x. My outer two terms together, the x and the 6 are on the outside, so I get plus 6x. My inner two terms together to get plus 4x. And then my last two terms of my binomials together, you get 24. And I combine like terms. Do this process again for number 2. My first together, x times x is x squared, minus 8x. Inner ones go together, so I get minus 1x, or minus x. And my last one's plus 8. And when I combine my like terms now, I get x squared minus 9x plus 8. Two more examples of binomials. 2x squared minus 18x plus 5x minus 45 gives us 2x squared when we combine like terms minus 13x minus 45. And this last example is important to show because you will not always need to combine like terms at the end. So when I multiply these binomials, 12x to the third plus 15x plus 8x squared plus 10, you'll notice I didn't get any like terms, so I'm just simply going to rewrite my final answer in descending order. So we've worked a lot with multiplying two binomials. Let's just look at two more examples of when we're multiplying other types of polynomials that are more than just two binomials. Here you notice that in this first example, I'm multiplying a binomial with a trinomial. Now, I could represent this on a rectangle. And find all 6 of these smaller areas and then add them up. Or I could just remember my rule for multiplying polynomials, which is you distribute each term of the first polynomial with each term of the second polynomial, and then repeat that for the second term. So let's just do the distribution. X times x squared is x to the third. X times 9x is 9x squared, and x times 8 is 8x. And I notice I missed my 9x squared, so I fixed that. Now I distribute the 3 into all 3 of those terms as well. Plus 3x squared plus 27x plus 24. Notice I can't use FOIL here because I'm not multiplying two binomials together. So I just have to remember to distribute, in this case, 6 times. And now, again, I'm going to look for like terms to combine. X to the third plus 12x squared plus 35x plus 24. You can see that my like terms were there and there. And our final step here is to show what it would look like to multiply two trinomials together. Again, I've shown you a picture of a rectangle, but rather than using a rectangle to multiply, let's just use distribution. And in this case, I'm going to need to multiply 9 times in order to distribute all of my terms properly. So let's start with distributing our x squared. We get 2x to the fourth minus x to the third plus 10x squared. Now I jump to my second term of the first polynomial. Plus 8x cubed minus 4x squared plus 40x. And now for my final term, the negative 5. Minus 10x squared plus 5x minus 50. And now you can assume that there will be a fair number of like terms. Let's combine them starting with our highest degree term, 2x to the 4th. And that's, I just carry that down. I don't have any other x to the 4ths. I now look for my x to the 3rds. I have 2 of them here that I'm going to combine. So I get plus 7x to the 3rd. When I combine my x squareds, here I have 3 of them. So I get 10x squared minus 4x squared is 6x squared. So minus 10 is negative 4x squared. Combine my x terms to get plus 45x. And then I'll carry down my final term, which is minus 50.